In this video, we're going to look at parabolas and straight lines and how to solve them. And so we've been given the two equations. And so if we're needing any x and y intercepts, for example, in the beginning we need c, which is the y-intercept of both. To get the y-intercept, we just let x equal 0. And so I can choose either graph. So I'm going to choose this one. And if x is 0, we get -3. But I'll write my answer as 0, -3. Calculate the length of AB. That is just your two x-intercepts of your parabola. And so I'm going to just head out that way. To get the x-intercepts, I'm just going to let y equal 0. And then I'm going to factorize this. And so a lot of your graph questions, you're just looking at zooming out and answering what are they basically asking me to do, rather than getting too lost in the details. So A is -1, B is 3. So the distance from A to B would be 4. Calculate the coordinates of D. And so that's just your turning point. So we're going to go to get the x value at the turning point. It's -b over 2a. Or if you're in matric watching this video, you could probably do derivative equals 0. So minus b, always keep it in brackets, over 2a. A is the number in front, and if there's nothing, it's 1. That just gives you positive 2 over 2, which is 1. So your turning point, you know, is at 1 and something. And what do you do whenever you're missing a letter in graphs? You just sub in. So I'm just going to sub 1 into here, and that spits out an answer of -4. So you've got the coordinates of D, it's 1 -4. Whenever they say coordinates, you must write it as the x and y value. Calculate the average gradient between C and D. So again, carefully in brackets, it's a change in y. So it's -3 -4. So I went this minus that. So then I must go 0 -1. Over the change in x, 0 -1. That gives me positive 4, -3 is 1 over -1. The gradient is -1. Last question, work out the size of OCB. Let me just call it theta for now. So you know that C is at -3 and B is at 3. And so these two lengths are the same. And this is 90 degrees. So the one way you could do it is seeing this as an isosceles triangle. And so both these angles would be 45. So the answer here is 45 degrees. Let me just show you a different method. Whenever I need angles, I can use this little formula, tan theta equals m. And so the gradient of this straight line is 1. And so I'm going to go tan theta equals 1. Anytime I need an angle, I press shift, and when I shift, I get 45 degrees. That's the angle that's made from the x-axis until it hits the line. So if that's 45, vertically opposite, this would be 45. And then if you wanted to, you could have done sum of triangle. This equals 45. I'm just showing you this method because sometimes questions can be a lot trickier. You'll have these trickier questions when you've got to work out an angle in the middle of nowhere. And the trick for that is you work out the gradient of both lines that touch theta. Then you go tan theta equals m and shift tan m for both lines. And that would give you, for example, the angle would be 70 and the acute angle might be 30. And then step 3, you'd have to do some version of vertically opposite or sum of triangle or angles on straight line, something like that to bring all the information closer. So in this little quick made up example, that would be vertically opposite 70. This would be vertically opposite 30. And so 70 and 30 is 100. So then this theta must be 80. Look out for this. This is quite a juicy 5-mark question to find out the angle in the middle of nowhere. I hope that you found this example helpful. If you did, please like this video, subscribe to our channel, and share it with your friends.